Today we're going to talk about solving systems of linear equations by substitution. So substitution is just one of the methods that you can use in order to solve a system of linear equations. And remember, a system is just two or more equations grouped together that we're going to find the solution of. So take a second, pause the video here, and copy down these 3 steps up at the top for how to solve a system of linear equations by substitution. So step 1, solve one of the equations for one of the variables. That means just isolating the variable or getting one of the variables by itself. Step 2, substitute the expression from step 1 into the other equations and solve for the other variable. Step 3, substitute the value from step 2 into one of the original equations and solve. So you don't necessarily have to know what all these steps mean right now, but they are going to be helpful to be able to go back to once we kind of do some examples together. So for example 1, solve the system of linear equations by substitution. We'll start with 1a. So we're given the equation y equals 3x plus 14 and y equals negative 4x. So step 1 says to solve one of the equations for one of the variables. In part A, both of these equations are already solved for y. So we don't need to do anything for that step because they're already solved for one of the variables. And then for the first equation, we're given y equals 3x plus 14, and the second equation we're given y equals negative 4x. So what we can do is we can take this negative 4x, because we're saying that y is equal to negative 4x, and we can substitute it into the other equation where y is. So we're taking this 4x, and we're going to substitute it into the other equation where y is, because we're saying that y is equal to negative 4x, so it's okay to substitute into the other equation where y is. So when we do that, this first equation, which started off as y equals, becomes negative 4x equals. And then the rest of the equation stays the same, so 3x plus 14. So now I have the equation negative 4x equals 3x plus 14. And now I can solve this equation using the same steps that we've used throughout the year. So negative 4x equals 3x plus 14. I want to get all of my x's on one side of the equal sign first. So I'm going to move this 3x over. I'm going to undo this positive 3x by subtracting 3x from both sides. So when I do that, negative 4x minus 3x, you subtract the coefficients, the numbers in front. Negative 4 minus 3 is negative 7x. And then equals 3x minus 3x, that cancels out, and then I'll bring down the 14. And then negative 7x equals 14. So if I want to get x by itself in order to solve for it, I need to undo multiplying by negative 7. So I'm going to undo it by dividing both sides by negative 7. Then multiplying and dividing by negative 7 undo each other. I'm just left with x equals 14 divided by negative 7 is negative 2. So that's 1/2 of our solution. So we figured out that x equals negative 2. Remember that a solution for a system of equations is a point. So we need to find an x and a y coordinate of that point. So once we've found the x, we can pick one of our 2 original equations and substitute our x value in to solve for y. So just pick whichever one looks easier to you. I think the second one looks easier, so I'm going to rewrite that up here. So y equals negative 4x. And then in order to solve for y, I'm going to take my x equals negative 2, and I'm going to substitute that in where x is. So this equation becomes y equals negative 4 times, instead of times x, it'll be times negative 2. And then y equals negative 4 times negative 2 is positive 8. So we got y equals 8, and then so our final solution is, we write it as xy, like a point, negative 2, 8. So for example B, our equations are x equals 6y minus 7 and 4x plus y equals -3. So the first step above, it says to solve one of the equations for one of the variables. So this first equation is already solved for x. It has x by itself on one side of the equal sign. That means it's solved for x. Step 2 says substitute the expression from step 1 into the other equations and solve for the other variable. So we're going to take what we're saying x is equal to. So we said x is equal to 6y minus 7. And we're going to substitute that into the other equation where x is. So this 6y minus 7 is going to replace the x in the second equation. So it doesn't matter which one you substitute in where, whether it's equation 1 or equation 2. You just have to make sure that you solve for one of the variables before doing so. So I'm going to take this 6y minus 7 and substitute it into the second equation where x is. So the second equation becomes 4, instead of times x, it's going to be times all of this. So it'll go in parentheses. So 4 times 6y minus 7. So that's just the 4x part right now. And then plus y. And then equals -3. And then now we have an equation that just has y, so we can solve for y. So before I can start moving things from side to side, I need to simplify each side of the equation first. So I'm going to have to simplify this left side. So I'll do so by distributing the 4. So 4 times 6y is, you just multiply the numbers in front, so 24y. 4y times 6y becomes 24y. 4 times a -7, that becomes -28. Plus y equals -3. Everything else just comes down to plus y and the equals -3. And then we have some like terms that we can simplify. So we can combine like terms, which those just have the same variable with the same exponent. So 24y and 1y. We can combine those into 24y plus another y becomes 25y. Minus 28 equals -3. So now I have 25y minus 28 equals -3. I want to solve for y, so my goal is to isolate it and move everything away from it. So I have a 25 being multiplied by y, and I have a 28 subtracted from it. So I'm going to undo the subtraction first. I'm going to add 28 to both sides. So I can bring down the 25y. -28 plus 28 cancels out, and then -3 plus 28. So these have different signs. One is a negative and one is a positive. So we take the difference between the two numbers. The difference between 28 and 3 is 25. And then the sign from the larger number. So there's more positives. There's 28 positives and 3 negatives. So our answer will be positive. And then now we have 25y equals 25. So to undo multiplying by 25, I'm going to divide both sides by 25. This 25 divided by 25 cancels out, undoes each other, so I'm just left with y. And then 25 divided by 25 is 1. Anything divided by itself is 1. So we figured out that y equals 1, and now we want to solve for x. So we can take our y equals 1 and substitute it into one of the two original equations. It doesn't matter which one, pick whichever one you think is easier. So I'm going to use the first one, so I'm going to rewrite it up here. So x equals 6y minus 7, but I'm going to take the y equals 1 and substitute it into the equation where y is. So x equals 6 times y becomes 6 times 1 minus 7. And then from here we just need to simplify to solve for x. So 6 times 1 is 6, and then bring down the minus 7. And then 6 minus 7 is -1. So we end up with x equals -1 as our x value, and then we just need to write our final point as, or our final solution as a point. So like x comma y in parentheses. So our final solution will be -1 comma 1. It'll always be in that order too, so make sure you pay attention to what x and y are. You're not just looking at what value are you solving for first. So our final solution is negative 1, 1. For part C, we have y equals negative 2x minus 9 and 6x minus 5y equals negative 19. So step 1 tells us that we need to solve one of the equations for one of the variables. The first equation is already solved for y because it has y by itself on that side of the equal sign. So if I'm saying that y is equal to negative 2x minus 9, then I can substitute that negative 2x minus 9 into the other equation where y is, because I'm saying that y is equal to this, so this can replace y in the other equation. So negative 2x minus 9 is going to replace y, and I need to make sure it goes in parentheses so I can distribute. So the second equation becomes 6x minus 5. Instead of times y, it'll be times all of this because we're saying that y is equal to this. So 5 times, this will go in parentheses, negative 2x minus 9. And then we have the equal sign that came after this y, negative 19. And then now we have an equation that just has x's, so we want to solve for x, but first we have to simplify the left side of the equal sign. So I'm just going to bring down this 6x, and then I have to distribute this negative 5. I have to be really careful with my negative signs here. So a negative 5 times a negative 2x, I just multiply the coefficients. Negative 5 times negative 2 is positive 10, and that x just tags along. So negative 5 times negative 2x is positive 10x, and negative 5 times a negative 9 becomes a positive 45. Remember, a negative times a negative, or an even amount of negatives multiplied together, becomes a positive. And then equals negative 19. And then from there, I need to combine like terms. So 6x and 10x, those are both like terms. So 6x plus 10x, I just need to add the coefficients. That becomes 16x. I can bring down the plus 45 and the negative 19. So now I have 16x plus 45 equals negative 19. I want to solve for x, so I'm going to move everything away from the x. So I can undo this plus 45 by subtracting 45 from both sides. I'm going to bring down the 16x. 45 minus 45 cancels out. I'll bring down the equal sign, and then negative 19 minus 45. If you want to use a calculator, it's totally fine. Just make sure you're careful with your negative signs and you double check it. So if you have a calculator like this, you can do the negative sign is down here. So down here at the bottom, so negative 19 minus 45. So that's negative 64. And then now we have 16x equals negative 64. So to undo multiplying by 16, I'm going to divide both sides by 16. So multiplying by 16, dividing by 16 undo each other. I'm left with x equals, and then negative 64 divided by 16. You can also do this in the calculator. I already have the negative 64 up there. So I can just hit divide by 16. So negative 64 divided by 16 is negative 4. And if you didn't already have the negative 64 up there, you just do negative 64 divided by 16. And then we're good, negative 4. So we ended up with x equals negative 4, but we still need to find the y value that goes along with that. So we can take that x equals negative 4 and substitute it into one of the original equations and solve for y. So pick whichever one you want, whichever one you think is easier. I'm going to use the first one. So I'll rewrite it over here. Y equals negative 2x minus 9. And then this negative 4 will go into that equation where x is, because we're saying that x is equal to negative 4. So y equals negative 2 times x becomes negative 2 times negative 4. Right, negative 4 just goes in for x, and then minus 9. And now we just need to simplify to solve for y. So y equals negative 2 times negative 4 becomes positive 8. Minus 9, bring down the minus 9. And then 8 minus 9 is negative 1. So we end up with y equals negative 1. And then we got x equals negative 4, y equals negative 1. So our solution will write in xy order. It'll be negative 4, comma, negative 1.